So what we are going to do is just like in sampling a uniform direction on the hemisphere, what were we doing? So we were randomly selecting a direction, right? So we were randomly selecting a theta and phi on the upper hemisphere. Now it is very similar, except that we want to restrict ourselves to selecting the following. We want to restrict ourselves to selecting a direction. Okay, so this is the full thing. We will be sampling a direction that is in this range. Okay, so here we will be selecting something in this range, and this angle here is theta max. Okay, so let's also remember the relationship that we had between spherical coordinates and the direction. So the probability density p theta phi was equal to sin theta pw. Okay, and we want uniform probability. We want this to be 1 over so we call this C, right? We call this thing PWC because I want equal probability for everything here. So my P theta phi is equal to sin theta times C. Okay. Now it's going to be almost like the same thing that we have done before, but now we are going to write the integral. So we need to find this C term here, right? What is this C? Actually, I should better write it like C times sin theta. Now, from 0 to 2 pi, now this time from 0 to theta max, okay? So previously, this integral was going from 0 to pi over 2 because we were sampling all possible directions on the sphere, on the hemisphere. Now, as I have drawn, we want to only limit ourselves to a smaller range this time. Okay? So this integral, what are we integrating? We are integrating this thing, C times sin theta, and d phi, d theta should be equal to 1, right? Because we want this to be a probability density. This is the probability density, theta phi. Now, if you carry out, go ahead with the integration, you are going to obtain the following. This is equal to, from here, we are going to find 2 pi c minus cos theta. Okay, 2 pi c minus cos theta. And theta max, from theta max to 0 is equal to 1. Okay? And if you proceed one more step, from here we find that C is equal to 1 over 2 pi 1 minus cos theta max. Okay? So then our P theta phi function becomes sin theta divided by 2 pi 1 minus cos theta max. Okay, so we continue in the exact same way as we have done in last lecture videos. For this to be in order to sample from this distribution, we are trying to separate this into two PDFs. We want this to be separable. Now, luckily, this is also separable. So here, this can be like this part could be your P theta. Okay, so this is your P theta, and this is the P phi. Okay, so note that they must integrate to 1 in their respective domains. This integrates to 1 over 2 pi integrates to 1. Okay, and this also integrates to 1. We just did it. Okay, so now with this, from here, this is P phi, this is P theta. Okay, so let me write again one more time. P phi is equal to 1 over 2 pi, okay, and P theta is equal to sin theta divided by 1 minus cos theta max. Okay, now how do we well, we know how to uniformly sample this probability, right? But what we don't know is how we can uniformly sample from here. So we use the same procedure. We compute the CDF and then we invert the CDF. Okay? So what we do is then let's compute the CDF for this one. Px is equal to from 0 to x p theta d theta. Okay? And if you go ahead with the integration, you find the following. This is equal to 1 minus cos x divided by 1 minus cos theta max. Okay, so this is the CDF. This is the CDF. And then we must invert this CDF. So let's do that here. The inverted CDF is the following. P minus 1 x is, so the inverted, this, if once we invert this, we find the following. So let me write a little bit here. P minus 1 x is equal to cosinus minus 1 1 minus x plus x times cosinus theta max. Okay, so cos in arc cos and in parentheses 1 minus x plus x times cosinus theta max. Okay, so once we have this, we can compute our theta as follows. So you will be sampling, right? So I want my theta I is going to be inverse of this. Okay, in this one, psi 1 I, and my phi I is I know at this point is 2 pi psi